The purpose of this video is to assist students on lesson 3.4 out of our student assignments books. Now, this activity is supposed to be completed at home. Students were given some time to work on it in the classroom, but they were expected to finish it at home. I'm going to start at the beginning with the first part, and the directions read: fill in the missing numerator or denominator so the fraction is close to but greater than 1/2. Now, we've been working with benchmark fractions, and the three that we've been using are 0, half, and a whole. And we've been doing quite a bit of work with half, looking at fractions that are equal to half, such as 5/10, as well as fractions that are close to half, but not exactly. Maybe they're a little bit more or a little bit less. Um, 5/2, if we were to simplify it down, we could say 5 is the greatest common factor of both 5 and 10, and 5 divided by 5 would be 1, and 10 divided by 5 would be 2, so that is equivalent to half. Now our directions tell us that we need it to be a little bit greater than half. Now, I guess I've kind of reinvented the wheel because I'm sure this formula exists out there, but it kind of came to me a handy formula for trying to figure out what the numerator should be if you want to have a fraction that's very close to half, but just a little bit more than half. Could look something like this. Let's say that formula could look perhaps like this. Let's say that n stands for numerator, and the numerator times 2, and we will subtract 1 will give us a denominator that will produce a fraction that is close to but greater than 1/2. For instance, let's use this numerator 5. If we have 5 and we times it by 2, that's going to give us 10, and 10 take away 1 will give us 9. And if that is our denominator, and we have 5/9, that is a fraction that is close to but greater than half. Now this formula, numerator times 2, subtract 1 equals denominator, will work in this. Now this time we'll do an example of a fraction that's close to but greater than half by focusing on our denominator, like this one here, 10. This time our formula would be about the opposite. We would have the denominator divided by 2 plus 1 is going to give us the numerator that will produce a fraction that's close to but greater than half. For instance, if we have 10 here and we divide 10 by 2, that's going to give us 5, and 5 plus 1 is going to give us 6. So if we have 6 as our numerator and our denominator is 10, we have a fraction that is close to half, but it's greater. So this would be pretty handy for our activity that we're doing to start off. This formula, numerator times 2, subtract 1 equals denominator, will be a good formula to use when our numerator is given and we're having to come up with a denominator. The formula, denominator divided by 2 plus 1 equals numerator, will be handy when our denominator is given but not our numerator. So we'll use these formulas as we do the first 6 items. Okay, so once again our formula for finding the denominator to create a fraction that's close to but greater than half is numerator times 2, subtract 1 equals denominator. And the formula for finding the numerator to create a fraction that's close to but greater than half is denominator divided by 2 plus 1 equals numerator. Now, when we look at the first fraction up here, we are given the denominator of 15. Now, to find the numerator, all we have to do is use this formula here for finding the numerator. The denominator, in this case 15, divided by 2 plus 1 will give us the denominator. I'm sorry, the numerator. Now, 15 divided by 2 is going to give us 7.5, 7 and 5/10. Now, if we add 1 to that, that's going to give us 8.5 or 8 and 5/10. 8 and 5/10, we can't put a decimal up here, but all we really need is that 8. We don't even need to go to 9 to round up. We can just round down because 8 times 2 gives us 16. And since 8 over 16 will be exactly half, we really do need that one less here, that 15, and it will work. So 8 over 15 is a fraction that is very close to, but greater than, half. Now, with number 2, we have the denominator 11 provide for us. Now, all you have to do here is divide 11 by 2, add 1 to that quotient, or since we have an odd number, add 0.5 to it, and then that will give us our numerator. Now, this is a very general formula, so you may just have to add 0.5. You may not need to add a whole 1, but it will work in most of our situations here. So I'll leave that blank for you to try to answer on your own. Now, number 3 here, this time they give us a numerator. Now, with our fraction here to find, with our formula here to find the denominator, all we have to say is 7 times 2, subtract 1, and there we go. So 7 times 2 gives us a certain product. We subtract 1 from that product, and that will be our denominator. And I will leave that for you to fill in. Then, number 4, they give us a numerator. And once again, we have to find the denominator. So we will say 19 times 2, and we'll take that product, we'll subtract 1 from it, and it will give us our denominator. I'll leave that blank and give you a chance to answer that one on your own. Number 5, this time we're going to do the numerator. They give us the denominator, so we'll have to say 14 divided by 2, and that will give us a quotient. That's a whole number. We will add 1 to that quotient, and that will give us our numerator. Number 6, we are going to have the denominator given to us. If we take that denominator and we divide it by 2, and we add 1 to that, that will give us our numerator. Now, I'll pause it for a moment, or you can pause it and try to answer these. This next part of our lesson is super easy. Our instructions are that we need to fill in the missing numerator or denominator so the fraction is close to but less than 1. Now, to have a fraction that is equal to 1, we could write down 2 over 2 or 2 halves, and that will equal 1. Anytime your numerator is equal to your denominator, if it's a 2 here and a 2 here, you're producing a whole. If you have 10 over 10, you're still going to have one whole. If you have 99 over 99, you're still going to have one whole. Well, all this means is that there are 2 halves, and out of the 2 halves, we have both of them. We have both of them. So that will equal the whole. We have the whole thing. So if you have, for instance, a pizza, and you cut that pizza into halves, if you eat half of the pizza, and this will be surely a small personal pan pizza, if you eat half of it and then you eat the other half, you've eaten the whole thing. Now with 10 over 10, it's like you have 10 parts and you have all 10 of them, and 10 out of 10 will equal the whole. You have the whole thing. 99 out and 99. 99 over 99 is like having 99 pennies, and you don't have to share the pennies with anybody. You have all 99 of them. You have the whole lot. So that's what this means. So anytime you want to have a fraction that's close to but less than 1, your numerator has to be just 1 less than the denominator. For instance, if I want this fraction to be close to but less than 1, instead of 10 over 10, I'll just have 9 over 10. Instead of 99 over 99, I would just have 98 over 99. Now, I will say this. This technique that we're using, just taking 1 away, it works when you have very large denominators like 10 and 99. Here where I have 2 over 2, if I take 1 away from that numerator and just have 1 over 2, I don't have a fraction that's close to 1. I have a fraction that is the benchmark half. So it only works with big denominators. It does not work with small denominators. I would not consider, for instance, 2 over 3 to be close to a whole. I just wouldn't. For instance, if you're talking about 2/3 of an hour, this would be equal to 40 minutes, and there's a big difference between 40 minutes and 60. Let's look at 3/4. I wouldn't say that this is very close to, but less than a whole, just because 3/4 is still it's still too small, and that difference is huge. 25% difference is pretty big. It's like the difference in getting 100 on a test and 75% on a test. It's a huge difference. You go from an A to a C. Now, I would think it would be pretty acceptable, perhaps, at least for my students in my assignment, that if you have 4/5, that is close to a whole. So anything less than 5 as a denominator, it just would not touch that benchmark fraction of a whole. Now, with that said, we can go ahead and work on our uh, actual assignment where we fill in the missing numerator denominator. So the fraction is close to but less than 1. Okay, so let's say that they give us a denominator that is 9. Now I can't put 9 up here or I'll have a whole, but I can put 9, take away 1, and that'll give me 8, and 8 over 9 would be very close to, but would be less than a whole. Now with this one, let's say they give me the numerator 9. Now I can't put 9 here, that'll be exactly a whole, but I can add 1 to it. 9 plus 1 gives me 10, and now I have a fraction that is close to but less than 1. The rest of these, I'm just going to plug in a numerator or a denominator and let you have a chance to do this part on your own.